Here we go. All right, so this is notes number 4 for us, I believe. Anybody confirm that? Bless you.
Thank you. Teresa. Did you say Teresa? I said Teresa. Oh.
Okay, these are applications of exponential functions. Basically word problems. Yay, word problems!
She's probably been doing this for 10 years and she's like still happy.
Yes, I have been doing this for 10 years, and yes, I am still happy, so thank you.
Every semester. Applications of exponential functions.
I mean, you know, at least I'm not sad about it. Okay, so here are your formulas. Yeah? Is that not good? You have an increase formula.
That's too many.
And a decrease formula. To me, these are easy, but I guess I'm a math nerd. So I'm not a math nerd, but
I'll give you that.
Okay, thanks. All right. So your increase formula is A equals P parentheses 1 plus R close parentheses to the T.
Is that 1 plus P-O-R?
Yeah. 1 plus R to the T power. The decrease formula will be very similar. It's going to be A equals P times 1 minus R to the T. All right, so let's talk about each of the variables that I've just listed. A represents the final amount. R is the interest rate or percent as a decimal. So you're going to have to take the number that they give you and divide by 100 to get the number we're going to put in this formula. So that's really important. And T is time. Usually listed in years or months or whatever. All right, so we only have 3 variables that we're working with right now. There are some more complex formulas that we'll look at, but these are the basic ones. So today, what we're going to do is find the final amount, and, oh, I didn't write what P was. Sorry, I'm missing one. P is the initial amount. Initial? That's what I wrote. So the initial amount of money or people, etc. So basically, we'll be plugging in for P, R, and T, and using a calculator or Desmos or whatever to give us the answer. All right, so there are 3 types of problems that we will practice. So we'll look at an example of each of those. And we'll determine what the P and the R and the T are. Okay. Example 1. A town has a population of 16,000 and grows 6.5% every year. What will be the population after 12 years? Okay. There we go. Ish, uh-huh. All right, so,
Can I finish writing this?
oh yes, of course.
She woke up and decided.
I just want to peg you.
Who, me or him? It took me like 3 days to read it.
Yes, of course. Okay, So in looking at this word problem, there is some important information that I'm going to highlight. So a town has a population of 16,000 and grows 6.5%. What will be the population after 12 years? All right, so because of the word grows, we're going to use the increasing formula. A equals P times 1 plus R to the T. So the fact that it's growing or increasing, it is how I choose which formula to use. All right, so the initial amount of people is 16,000. So A equals 16,000 parentheses 1 plus R is tricky because we have to take that percent, so 6.5, and divide it by 100. So we take the given percent and we divide it by 100 before we put it into our formula. So 6.5 divided by 100 is 0.065. All right, so that's good. I like that you said that. So really, we are just moving the decimal 2 places to the left. But I feel like I've tried to teach it that way before, and students have just been like all over the place with like where they put that decimal. So I'm going with divide by 100 just for simplicity's sake. And so then Jeremiah says 12 is time or t. So that is an exponent. Please make sure that's itty bitty up there. And so I don't think that you'll be able to calculate this with your phone. I don't know about the exponents on that. So it'd be great if you had some sort of calculator to use. If not, you could use the Desmos calculator, and we can look at that in just a minute. So we'll put 16,000 parentheses, oops, can't see what I'm doing, 1 plus 0.065 parentheses to the 12. So I'm just putting all of the information in there. So when you're talking about population or people, they don't want a decimal. So we're going to have to look at this 34065, and we're going to have to determine if we need to round up or leave it the same. So you're always looking to the number to the right to determine that. So are we going to round this 5 up to a 6? Right. We're going to round it up to a 6. So we'll determine that the population after 12 years is 34066. 34066. All doing okay? All right, I'm going to show you I've got two more examples to show you. Can I keep going? Here's another example. So $8,200 is placed in an account with an annual interest rate
Miss, why don't you put $200 on it?
I don't know.
Oh, no. That's $8,200, right?
Uh-huh.
Okay, there's a way to
Okay. Of 7.25%.
We can use it,
How much will be in the account after 18 years?
I got you, okay.
So I'm going to highlight the important information. We've got $8,200, an interest rate of 7.25%. How much after 18 years? So I know it doesn't say explicitly that the money is going to increase, but theoretically you're putting this money in the bank. Say your grandpa, right? He puts this money in the bank the moment you're born, and he's going to allow you to take it out of the bank when you're 18 years old. Wouldn't that be nice? We're going to see how much you're going to pull out of the bank on your 18th birthday. So it should be increasing. We're pretending like this money is not coming out of the bank.
Oh, so we're going to increase.
Yes, this is an increase. So I know they don't specifically say it, but this is an increasing example. So again, we're using that formula. A equals P parentheses 1 plus R to the T. Okay. So the initial investment is the P, 8,200 parentheses 1 plus, and this is the tricky part. You've got to take this percentage. They said it's your rate, your R, and whatever's given to you, you have to divide that by 100 before you place it into your formula. 0.0725. Oops. To the 18th power. Yep. All right, so I'm just going to plug 8200 parentheses 1 plus 0.0725 to the 18th power. Wow, so that's a lot of money. I don't think banks are giving out those kinds of interest rates anymore, but this is just a theoretical problem. But anyway, so what we're going to record now, we're talking about dollars. So you would want every single penny that the bank owed you after 18 years. So since we're not talking about population and people, we're talking about money, we're going to take 2 decimal places this time. So I'm going to record $28,904, and so it's for this 8 is going to round to a 9, since that 7, anything 5 or more makes this round up, so it's going to be 0.49, and it's because we're talking about money. And Delta Math is going to remind you when they want cents and when they want whole numbers for people. So don't stress too much about when do I need decimals and when do I not. They'll tell you, you know, round to the nearest whole number or round to the nearest cent in the problem. All right, I've got one more problem to show you, and it's an example of decrease. A new car is purchased for, let's do 18,925. Yeah, for a new car it is, you're right.
That's like for a used car maybe.
Okay. The value of the car depreciates yeah, that's what they call it for cars. It's got like a special name. At 12.9% per year.
Is that what it is right now, or are you just making it up?
I'm making it up, but we can research what the depreciation rate. When I did this lesson last year, I like looked up stats and all of that for like actual stuff, but I'm trying to model what I saw in Delta Math, and these are the types of numbers they're using. So I wanted it to be like your practice. It's a little less than. I think the depreciation rate is actually higher, to be honest with you, but it depends on the car. Like a Honda doesn't depreciate as fast as, say, like a Kia. You know, if it's a lesser brand. But we can take a look at it if you'd like. Okay, what would the value be? Hold on, I'll tell you about that in just a second. So Jeremiah asked about this per year right here, and they're saying that because we're using the basic formula. There is a more complex formula that it compounds the percentage rate more than just one time per year, so we have to take that into account. So this basically is just telling you like this is like simple math. They're not like doing the most. Okay, but we're going to highlight the important information. Oh, wait. Yeah. So we've got $18,000. The value of the car, this was a new word for some of us, depreciates at 12.9%. What will the value of the car be after 7 years? So that word depreciates means it loses value. So that's going to make us use the decrease formula. And that only changes the fact that it's not a plus in the middle, now it's a minus. Because the cars will lose value as you nick and ding them around the way, or maybe you have an accident or whatever. Cars lose value. They're not worth as much as when you first started. So our initial amount is P. So A equals 18,925 times. Hello. Okay. Thank you. Are you going home? Is this for him to leave? Oh no.
That's tough. I hope you die.
I'm so sorry. Do you know anything about this?
Yeah, I just have to get it checked. I'll call you back.
Okay. So 1 minus, make sure you're not using the plus this time. We're going to take 12.9, the one that's given, and divide it by 100 in order to get our rate. So I get
Headphones in your ear.
0.129
You said what?
to the 7th power. So I've got 18925 times 1 minus 0.129 to the 7th. So again, we're talking about money, dollars, and Delta Math will ask you, they want it to the nearest cent. So this will be $7,197.19. So I don't have to do.
Hospital chicken. You know, like the cafeteria in the hospital? That's what it smells like.
I don't know, dear. All right. So those are the types of problems you'll see in your Delta Math assignment today. I want you guys to work on it. You